For fossil fuel resources, be able to discuss the use of coal and its consequences, the use of petroleum and its consequences, the use of natural gas and its consequences, and discuss the use of oil sands and liquefied coal and their consequences. And then describe the future prospects for fossil fuel use. What does the future hold for our fossil fuel resources? Other types of fossil fuel deposits contain a great deal of energy, but they're not really readily available. So when we consider using energy resources, it's important to determine if the energy return on the energy investment is going to outweigh it. So there are two less readily available candidates for fossil fuels, and they are oil sands and liquid coal. So not all petroleum is easily extractable from these oil wells. Not all petroleum is easily extractable in the conventional oil well. Oil sands are slow-flowing, viscous deposits of bitumen mixed with sand, water, and clay. Bitumen is a degraded type of petroleum that forms when petroleum deposits are not capped from that non-porous rock. And the petroleum migrates close to the surface, where bacteria metabolize some of the light hydrocarbons while it tends to evaporate. So the remaining mixture no longer flows at ambient temperatures and pressures, but it can be extracted by surface mining. So although oil sand and has some promise, it definitely impacts our petroleum supply, and it can also have a serious negative environmental impact. The mining of bitumen is much more energy intensive than conventional drilling, and more energy intensive than drilling for just the crude oil itself. Availability of petroleum may become much more limited in the century that you're going to live in as supplies diminish. And the United States and China both have immense coal reserves. So the technology to convert solid coal into liquid fuel is a process that we call CTL, and it stands for coal to liquid. And it's been available for decades, but CTL was widely used by the German military in World War II, and it's been used in other countries since then. But producing this liquefied coal is relatively expensive and has many of the same drawbacks from the oil sands. So in terms of total energy content, there's over 1,000 times more energy in the world coal reserves than there are in the petroleum reserves. So because there's so much coal in the United States, the CTL has the potential to eliminate the U.S. dependence on foreign oil, period. On the other hand, the U.S. Environmental Protection Agency, the EPA, estimates that the total greenhouse gas emissions from this liquefied coal are more than twice of those from the just conventional way that we produce oil. And as we've seen, the environmental impacts of coal mining can be pretty severe. And so for these reasons, liquid coal is not highly promising, but it's an important future energy source to consider. Although we know that the supply of fossil fuels is finite, there are some discussions within the environmental science community on whether or not that really even matters. If you recall before, we've talked about human creativity. So many people believe that we will apply human ingenuity to develop new energy sources. And in the meantime, the total energy use will level off. And energy use per person has decreased kind of slightly here recently. So that's in addition to energy per unit of gross domestic product. We know that as GDP. When we talk about that together, it's called energy intensity. And energy intensity is that energy that we use per unit of GDP. Our energy use per capita has been dropping, but with rising population numbers, total energy continues to rise. In this graph, you can see the per capita energy use, how it's plateaued, but the energy use per dollar of GDP has definitely declined. So, in other words, we are using more energy efficiently, but because human population has grown so much, we are doing more things that use energy. our overall energy has not really decreased. And if you think about how many electric devices you have, then ask your parents or even your grandparents how many electronic devices that they used to have when they were a high school student. You can see that there's definitely a difference. We'll begin now by talking about an idea about the availability of fuel and its use over time. And then we probably should look at some possible patterns of fossil fuel energy, in the use in the future. We have seen that fossil fuels, our primary source of energy, are finite. Because fossil fuels take the millions of years to form, they're a non-renewable energy source, at least, by the human timescale anyway. By definition, then, we use fossil fuels. It's not as sustainable because there's no way to limit our consumption at the rate at which we use them and at the rate at which they're being formed. So experts have debated whether our economy will have to, at some point, be limited by the availability of energy resources. Although in recent years, concerns have shifted away from the actual supply of fossil fuels to the consequences of fossil fuel combustion, particularly that release of carbon dioxide and its combustion to global warming. But many environmental scientists believe that these consequences will manifest themselves in adverse ways long after we run out of fossil fuel. There's still a group of energy analysts who are deeply concerned about the end of oil. In 1969, King Hubert, that was his name, he was a geophysicist and oil company employee, published the graph that you're seeing right here. It's this bell-shaped curve that represents oil use. The Hubert curve represents oil use and projecting both when the world oil production will reach its maximum and when oil will finally be depleted. Hubert used two estimates of total world petroleum reserves, an upper estimate and a lower estimate. He found that the total reserves did not greatly influence the time it would take to use up all of the oils in known reserves. He predicted that oil extraction and use would increase steadily until roughly half of the oil supply had been used up, and at that point, that would be known as peak oil. So back in the 60s, Hubert predicted that 80% of the world's total oil supply would be all used up in roughly 60 years. Although there have been many discoveries of large oil fields since Hubert did his work, the conclusion drew from his model, still holds true, regardless of the exact amount of the total reserves. If current global use patterns continue and no significant additional oil supply can be discovered, we may run out of conventional oil supplies here in less than 50 years. Natural gas supplies will last a little longer, and coal supplies will last probably 200 years, and probably much longer than that. While these predictions assume that we will continue to use in our current pattern, advances in technology and a shift in non-fossil fuel energies or changes in social choices and population patterns, all of this can alter that. And as people have come to accept the theory that, as anthropogenic increases atmospheric greenhouse gases concentrations have been caused by global climate change, a large number of researchers have suggested that we should turn our attention to how we might transition from fossil fuels before we cause a bunch of other problems. There are concerns about the scarcity and environmental impacts, especially about that CO2 on global climate change topic, and rising costs of fossil fuels present many opportunities. And rising oil prices create a powerful incentive to invest in alternative energy resources and even conservation. We've only begun to explore some possibilities in new infrared delivery of wind energy, hydroelectricity, solar energy. And on the other hand, the higher price of oil makes formerly these unproductive mining and extraction methods pretty cost competitive, so which may encourage a greater total production of fossil fuels. In this section, it was important to gather the advantages and disadvantages of oil, coal, natural gas, and nuclear. Think about how these things are significant, how the advantages or disadvantages, one outweigh the other. Is something more energy dense than other things? Who poses the most environmental risk? And really, who doesn't have the public support?